Good evening, dignitaries, and good evening, everyone. Myself, Veerakumar Rangasamy, with my professor Jyh-Bin from National Central University of Taiwan, would like to express some information about generative design for prefabricated structures using BIM and IoT applications. What are its current approaches and requirements? So here are my contents of this presentation. We have divided into 5 sections: introduction with GD-BIM integration, and the methodology we followed, the results, analysis and discussions, followed by the conclusions. To begin with, I would like to throw some information, a basic definition on the key terms: prefabricated construction. So in the prefabricated construction, building components are fabricated in the controlled environment, as we are aware about it, and it is transported to the construction site for installation. It may be fully or partially assembled in the site, the factory, and then it is transferred to the site for installation, and it follows various steps. So coming to the BIM, as we know that as per NBIM states that digital representation of physical and functional characteristics of a facility, and it's a shared knowledge resource for information about a facility, forming a reliable basis for the decisions during its whole life cycle. And what is GD, generative design? It's an innovative approach that utilizes the advanced computational algorithms and, of course, of AI, artificial intelligence, to generate and optimize the design solutions that is created for AEC industry. It involves the use of algorithms to explore a wide range of design possibilities, and it can generate multiple alternatives based on the designed criteria and constraints. So the research background is like PC is regarded as the first step towards the industrialization in construction industry, followed by the mechanization, automatic control, and productions. And the real-time adoption is hindered by the factors like expensive design costs, significant capital expenditures, and lack of supply chain data, etc. And GD is currently being integrated in the construction industry, especially in the traditional constructions, which can improve the benefits of BIM. And this integration of GD and BIM in PC could enhance the interest towards its implementation. This not only improves the BIM capability to generate wide range of design in short duration, as well it helps to optimize the design cost and, of course, the early design freeze. When it comes to prefabricated construction, it is mandatory to have the early design freeze concepts. So the research scopes are GD-BIM integration in traditional construction is quite high, whereas in PC, very few papers have been discussing about this one, and only few papers investigated GD-BIM integration with PC to effectively address the design difficulties, while the other papers discuss about the software and the programming techniques rather than the designs. And the objectives is to evaluate the prevailing studies in terms of their bibliometric data, and to understand the methodological connections, skill requirements, and the improvements to help the designers and researchers. So coming to the GD-BIM integration. So GD assists the professional designers, architects, and civil engineers to automate portions of the design process using computational approaches. And it has 3 important steps. One is parametric design, that is generate, and simulation, that is evaluate, and optimization, that is evaluate. And here is the flowchart for the GD process. It's a simple one, which follows 3 components. That is to define design goals, and next is the algorithm, and third one is the design constraints. So what is an algorithm? It's a set of rules that a computer must follow to execute the computations, as you are aware about it. And some of the most popular architectural design algorithms that are commonly implemented in this GD are cellular automata, genetic algorithms, L systems, shape grammars, and swarm intelligence, etc. Algorithm selection depends on the characteristics of our design goals. And for instance, we could say the generative algorithm is widely applied for design optimization and improvement. What is design constraints? These are a set of design criteria or goals, such as design restrictions, material choices, sizes, weights, etc., manufacturing process, or even financial restrictions. The same design objectives or limitations cannot be applied to every building project, since PC is very specific to the project. For example, some projects might concentrate on design generations and optimization, other might concentrate on lighting and ventilation, and so on. So BIM and PC have shown greater improvements in design stages, cost calculations, supply chains, and logistics, etc. As we know that BIM has been in the 3D, 4D, 5D, 6D, etc. When it is wisely used, BIM can precisely describe the geometry, behavior, and characteristics of individual PC components and objects, making it easier to incorporate with the standard architectural paths. Some of the popular softwares are Revit, Tekla, Graphisoft, Bentley, and BIM 360. So BIM in PC have been widely discussed on fabrication, waste reduction, safety, etc. But when it comes to the design stages, especially the design development, structural design, MEP designs are relatively less. So these capabilities can be improved by integrating this AI technologies like GD, parametric modeling, etc. Softwares like Revit currently supports API, which enables users to add on plugins and they can play with this. So next, I'm moving to the methodology. Sorry. Next. Yeah. So regarding the methodology, we just acquired the articles from the Web of Science database because of its rigorous peer review process. For unbiased analysis and conclusion, we just used a mixed review method, that is quantitative bibliometric analysis and qualitative analysis. So here is the research steps. So GD is often related to the parametric design, algorithm design, and geometric modeling. So we just use all these keywords to get the articles. And the revised keywords produce 33 articles after the exclusion of alien studies. And this is the studies we followed, quantitative and qualitative. In quantitative analysis, we just use VOSViewer to explore the bibliometric data. And in qualitative analysis, we just use the in-depth analysis. So coming to the analysis part, so here is the trend of PC using GD and BIM. So we could see the recent years, we can find a lot of publication related to the GD-BIM integration in PC. We could say more than 9 publications in the 2022 year. So the bibliometric software VOSViewer is used to analyze the co-occurrence of keywords, article citations, and journal citations to provide some quantifiable perspective. So first, the co-occurrence of keywords, we just analyzed it widely to understand the subject matter and also to know the mainstream research area. The visualized network of keywords is shown in this figure with 47 nodes and 360 linkages and the total link strength of 84.50. So it is subjective again, we can change the parameters. So BIM, including its abbreviation, is most frequently occurred in the analysis with 83 links containing a total link strength of 23, and the successive keywords are prefabrication, construction, which are found with a common link strength 4, 10, and 9. So these are the top 10 keywords that we achieved from this analysis. We could see the optimization, design, model, internet, etc. DFMA, as one of our mate discussed about the DFMA, is here. And this is the picture. So the specific keywords like optimization, model, and so on, which occurred more than 5 times with at least 20 links, and the reasonable link strength clarifies that the authors pay more importance in applying the AI or IoT application in their research. And with the minimum 3 number of occurrences, generative design, algorithm, and parametric designs, it clearly mentions that the research is in the surface level. And coming to the citation analysis of articles, it's a method for determining the relative relevance or impact of an author, an article, or a publication by measuring the citations. The threshold is set up as 3, and we generated 24 documents out of 33, which is represented here. So the list of widely cited documents with minimum 25 citations and their link are listed here. We could see in the 2019 have got most number of citations, 149 with 7 links. Interestingly, this figure clearly shows that there are 9 articles that have citations, but there is no connection with the others which directly represents the status of research topic at its initial level. So the citation analysis of journals, again, there are 11 journals that we found in the analysis, and out of which automation construction has published more number of papers, and it is drastically high in comparing to the other publications. So coming to the qualitative analysis, the methodological linkages between GD-BIM development and the applicability of programming languages and the learning development of programming abilities will be discussed. So it is based on the co-occurrence of keywords. So we'll discuss about the objective-oriented GD-BIM in PC, skill-driven GD-BIM in PC. So objective-oriented GD-BIM has 2 points. One is it solves specific design tasks, which is typical to the project, and it can support the design process. So there are some authors, they discuss only specific to the design tasks, I mean specific to the projects, and there are some authors that they discussed about the GD-BIM integration in the wholesome area. So coming to the skill-driven GD-BIM adoption in PC, we can follow 2 programming languages. Either it could be a virtual programming languages or textual programming languages. For a beginners, we would recommend to go with the virtual programming languages like Dynamo, etc. So beginners, it would be easy and quick to learn simple software interactions. BPLs like Dynamo for Revit, Grasshopper for Rhino, and would perform a better GD for initiative and novice users. Whereas if someone is good with the programming, they could use the textual programming languages such as Python, C++, or JavaScript that can be integrated in the API. So there are a lot of algorithms that is being currently used, such as GAN, genetic algorithm, particle swarm algorithm, random forest, etc. And this application of AI algorithm may aid in data analysis, problem solving for design challenges, predictive modeling, timetables, etc. So this is the guidance to improve a skill learning for GD-BIM development for a designer without experience. So coming to the conclusion. So it is evident that the use of GD-BIM in PC is still its infancy, and only few studies have contributed towards GD-BIM in PC, and there is a growing interest towards GD-BIM in prefabricated construction. And with the help of AI, we could minimize the design costs that could enhance the implementation of PC, and we can integrate the early stages of MEP, lighting, and ventilation, etc. using GD-BIM integration. And the designer can have the idea about VPL and TPL here, which one is preferable, they can use it or adapt it to get benefit to the GD-BIM integration. Yeah, these are some algorithms. I think some of the recommendations I would like to show is like a strong potential to work with the VPL or TPL is required to use GD-BIM in PC and which can generate different design choices, and optimizing that at early design stages, which could maximize the PC benefits. A wholesome GD framework that incorporates all design criteria can be developed. An additional design process which more sophisticated and organized GD-BIM could be developed. Of course, now it's multidisciplinary research which needs yes, these are the references. Yes, thanks for everyone to